Okay, hi everybody. So what is the inverse function of this function? Well, let's give it a name, x, and I guess I'm thinking of it as a function from r to r. And we could call this copy of r by x and call this copy of r by y. And then we'd say, well, the output coordinate is equal to 3 times the input coordinate plus 5. I just subtracted 5. And divided by 3. And so actually there's another function that takes y and sends it to, and let's call this function little g, it sends it to y minus 5 over 3. Okay, and I could call this input x as well, but I really have two spaces here, and so it's actually helpful to give them different names. And why is that? Well, so if I do f to x, right, if I take x and send it by f, and then I take the result and send it by g, what will happen? Well, okay, I have to do g to, okay, so 3x plus 5, that's f of x. Now what does g do to a number? G takes that number, subtracts 5, and divides by 3. Okay, well, what is that? Well, 5 minus 5 is 0. 3x divided by 3 is x. So g of f of x is x again. G undid what f did. Okay, well, let's see. Does f undo what g does? Okay, so I first do g to y, and I get y minus 5 over 3, and then I have to take that and plug it into f and see what f does to it. Well, f does 3 times whatever the thing is, and then adds 5. I think you're going to see we get y again. So actually f of g of y is actually y again. And so even f undid what g does. Okay, so what is the inverse? So part C. Okay, we're apparently starting with part C. Part C, the inverse function sends y to y minus 5 over 3. And this function, g, is the inverse function of f. Okay. Part A, just in general, what is an inverse function? So we say that any map G is the inverse of f if G is equal to 1 over f, right? Because then G times f would be 1 over f times f, which is 1. No! Okay, this is unfortunate. The word inverse in this case would be a multiplicative inverse. Like the multiplicative inverse of 2 is 1/2, because 2 times 1/2 is 1. This is not what we mean by an inverse function. So let me, please, this was not correct. G is the inverse function of f if what? If G undoes what f does. And, okay, so let me just that's as a formula, so in words we have G undoes what f does. As a formula we have this, and it has to be for all x. Really, everything that f does has to be undone by G. And we need one more thing. F undoes what G does. Well, that means that f has to undo what G did for all y. That's it. one more. This one is what we will actually need. This is the whole point of this problem. Because we have a wonderful function. X gets sent to e to the x, where this is defined by some ridiculous limiting infinite process. But it's actually pretty computable. We can approximate this thing by taking not an infinite sum, but a finite sum, say 100 terms. In fact, we won't even need 100. 10 would probably be good, depending on what x we plug in. But we checked that this sum actually will make sense as long as we take enough partial sums. It's going to get as close as we want to the actual answer, because we checked that this is an absolutely convergent infinite series for every x in C. Infinite radius of convergence. Okay? But the problem is we would like to undo this. And that function is called log. And right now, nobody can compute the log of 3. So that's pretty bad. Now, the thing is, if we know a lot about this function, and if log is its inverse, then maybe we can use the derivative of the inverse to learn something. So let's see. Explain the derivative of the inverse function in terms of the derivative of the original function. Well, that's a lot of words. I don't know what that means. So let's try to figure it out. We're going to look at these equations. Okay? In particular, let's apply d dx to this equation here. And let's apply d dy to this equation. Well, why would we apply d dx here? Well, because this will be a 1. That's good. So let's see. Okay, 1 equals. So I just did d dx that side. Now let's do it to this side. So g is a function, right? So at every point, we actually get another number called the derivative. It's really going to be used as a scalar in a linear map at that point. But for functions from R to R, we actually just, each linear map is identified with a real number, and so we get another function, usually called g prime. Okay? So how do we take the derivative of this? Well, the chain rule. So chain rule. The derivative of this thing is, well, g prime of f of x times the derivative of the inside function. So g prime evaluated at f of x times the chain rule gives the derivative of the inside function, so that's the derivative f prime of x. Okay. So that's good. That's good. So what does that mean? Well, if we want, so let's say we're in the situation where we have x, or we have f, and let's say that f is actually the exponential function. So we know its derivative, f prime, is just, well, the exponential function again. So let's think about this in terms of we know, or if we know f prime, but not g prime. We just don't know what g prime does. We would like to know, how does g prime do stuff? Well, actually it won't be on all of the reals, but... Well, then we can look here and say, oh, well, let's solve for g prime. So g prime at f of x, well, what's f of x? F of x is y. Okay, well, I'll just write it for now. G prime of f of x equals 1 over f prime of x. Now, if we're in the situation where we know f prime, this is looking good, because all we need to do is just divide by f prime, and we might get g prime. And in fact, that's what happens. Remember, f of x we're calling y, and so then x is g of y, the inverse. And so we can replace x by g of y, and replace f of x by y, and what do we get? G prime of y is 1 over f prime of g of y. okay? So this formula, and I will just write it out, this formula is super useful if we don't know anything about G. If we know F and F prime, okay, my pen died. If we know F and F prime, like we're gonna know the exponential function and we know F prime is again the exponential function, then we can discover the derivative of log, the inverse function, which would be little g in this case. Okay, so if we know F and F prime, we can compute G prime. That's the whole point. We will use this in the next video. Can you do this? Can you do this on your own? Look at these 3 problems. Go to a blank sheet of paper, copy them down. Can you do it without looking at the video?